Okay, so now let us get to section 4.3, logarithmic functions now. Okay, now logarithmic function basically is, you could consider that it's just another way to write exponential equations. Okay, the statement say here is b to the a equal to c is equivalent to the statement log base b of c equal to a, where b is greater than 0, b is not equal to 1, and c must be positive. So therefore, again, make sure that you know that this number right here must be greater than 0, and also b is also must be greater than 0. Okay. However, a could be any numbers. Okay. Okay. Then now let us look at this. How do we actually back out? Let's write the form back and forth between the two forms now. Now, if I have again, if I have b to the a, okay, the base raised to the power of a exponents is equal to the answer c. Then when we write to try to write in logarithmic form, then I will have log base b, we have the same base, right, of the answer of the c is equal to the exponents. Okay, so therefore in this case, if we have 3 squared equal to 9, then I will have log base 3 of 9 equal to 2. Okay, and then if you know that 4 to the negative 2 is equal to 116, again, remember 4 to the negative 2 is equal to 1 over 4 squared, right? The negative exponent. So that's why it is equal to 116. Okay, so then in this case right here, I would like to write log. Now the base is 4 of the answer 116 is equal to the exponent is negative 2 then. Okay. Now here is sometime I actually I would like to talk about how do we write the exponential, not exponential but the log. Okay. Now for example, like log base 3 of 9 equal to 2. Then now you could consider that you have two lines here. Then you will put log here, and then the 3, the base is the number is a little bit smaller. Okay, and then kind of like put under the line. Okay, and then 9 is the same level as log is equal to 2. Okay, the reason is I have some student like write it like this. Okay, so sometimes I will have a hard time that you writing like log of 39 equal to 2, right? So therefore again, be careful about the writing. Okay, how you write log. Okay. Okay, then now the next one. If I have 6 to the power of 0, we know that 6 to the power of 0 is 1, right? Then now I will have log, what is the base? The base is 6 of, the answer is 1 is equal to 0, is equal to the exponents. Okay. And now how about square root of 81? We know that square root of 81 basically is the 81 to the 1/2 power, right? Yes. And then we know that this is equal to 9. So then in this case, I will have log base 81 of 9 is equal to the exponents 1/2 then. Okay, yes, okay. Then now, of course, right now, how do I write the log form back to exponential? The base is 3, the power is 4, 3 to the power 4 is 81. Yeah, okay, that's it. So now, right now, I have this problem. I have log base 2 of 8 equal to what? Now, when you consider, then you could consider that 2 to what power equal to 8, right? So if you know that 2 to the 3 power is equal to 8, then of course your answer will be 3 here then. Okay, so then now the last one, if we have 10 to what power equal to 10,000, then of course in this case we are counting how many 0, right? We know that we have 4 0 here. Okay. Then of course my answer would be 4. Okay, now a lot of students actually have a hard time to learn log. The reason is to log we have some properties, okay, that students need to memorize it. Okay, so first of all, I would like to introduce these 4 properties right here. I have log base a of 1 equal to 0. So in this case, then we know that here The reason is what is a to the power of 0 is always equal to 1. So if this is a number 1 right here, then we know that the answer must be 0. Then how about log base a of a? It must be 1 because the a to the power of 1 must be 8, right? Okay. So if these two numbers are the same, then you know that your answer is equal to 1. And then now the next one, log base a of a to the x equal to x. So the reason is a to the power of x must be equal to a to the x, right? Yeah, it is. Okay. So a to the power of x must be equal to a to the x. Okay. Now to this one, is what we call the identities then. Okay. Then the last one is really weird, that I have a raised to the power of log base a of x equal to x. Now you will notice that this base and this base must be the same number. If this is the case, then my answer is equal to x right here. Okay. Now, for example, like number 8, you have 2 raised to the power of log base 2 of 37. Then, of course, your answer would be 37. Okay. Now, how do we actually come up with the last property here? This last property basically is back to the definition. Okay, how do we define it? Do you see that I have b to the a equal to c, and is equivalent to log base b of c equal to a? And then look at this. What is a? A is log base b of c. Then you will replace this a by log base b of c. Okay. Then you will see that this is exactly what we have here to number 4. Okay. Again, b to the a equal to c, right? But what is a? A is log base b of c. Okay. Then this base and this base, they're the same. Okay. Then now, what I would like you to do is, I would like you to actually check this out, okay? To see if, again, using the 4 properties here to help us to finish the problem, okay? Okay. Then now, we have, again, this one, we have the same base, so we could use the property number 3, then I know that my exponent 4 is the answer. And how about this one? Now, to this one, if you don't know 64 is 4 to what power, then what we could do is we could use a factor tree. So then we know that 64 is 4 to the 3 power. So therefore my answer will be 3 then. Okay. And then this one, basically we could use the property number 2. And to this one, okay, so then we have to know that to this, we know that 7 root of 3 is 3 to the power of 1 over 7. Okay, so again, if you don't know this, go back to 4.0, okay, the review of the exponents then. Okay, so therefore my answer is equal to 1 over 7. Okay. And to this one, I believe that most of you actually know that 32 is 2 to the 5th, right? Okay. And then to this one, actually we could use the property number 1. So we know that to this one right here, basically it is equal to 0. And then to this one, of course, my answer is 8 then, right? Okay. Okay, so now the next one I would like to talk about is the 3 laws. Now these 3 laws right here is a lot of students actually make mistake, okay? Because they are, sometimes they look at some similar, and then they actually, I should say that they create their own rule to actually to deal with log. So that's why this is actually make this, sometimes it's hard for student to actually to finish the problem, okay? And so therefore, again, I have some warning here, okay? So let us look at the 3 laws first, okay? If we have log base a of a times b, then it is equal to log base a of a plus log base a of b. So if this is a multiplication, if this is a product right here, then we could separate this into the sum of 2 logs. If I have a quotient, a over b, then I will rewrite this into the difference of two logs. If I have a to the power of c, then in this case, I could bring the c down to make it become c times log basis of a, okay, become multiplications, okay. So a lot of students make the mistake is when they see the multiplication of two logs, I have log base, this means log basis of x times log basis of y, then they write down is the sum, which is not correct, okay. The next thing that students do make the mistake is when they see log basis of x plus y, then they thought that they could use distribution. They could distribute. Okay. Now remember, you cannot do this. Log is what we call an operator. So you could not distribute an operator. Okay. The next thing is, again, they saw it's kind of like the rule number 2, right? They feel that I have a division, I should have subtraction, which is incorrect. Okay. And sometimes a student just kind of, can I cancel the log? Again, you cannot cancel the log. And you could not combine log, okay? Now to this one, how come I could not bring the c to the front? Now you have to notice what is the difference. This one right here is the whole log basis of x, the whole thing raised to the power of c. In fact, to this one, we only have a raised to the power of c then, right? And to this one, same thing, because to this one right here is not xy raised to the power of c, only y raised to the power of c. So again, we could not bring the c to the front. Okay. However, if I have something like this, then in this case, yes, I will be able to bring the c to the front. Okay, they're different. Okay, so now, before I move on, I would like to let me show you why we get the 3 logs. Okay, okay. Okay, so first of all, what I would like to do here is I would like to have okay, so what I'm going to do here is I would like to, again, let me see. I'm going to let a equal to log basis of not a, let u. And then I'm going to let v equal to log basis of b. Then. Okay. Then, now of course, what we know here is we know that a to the u is equal to a, and then a to the v is equal to b, right? We'll be right back to the exponential equation then form, okay? Then now, let's try this. So if I have log basis of a times b, okay? So in this case, we could actually have log basis of, now remember a is a to the u, and b is a to the v, right? Okay. Then we notice that this is log basis of a to the u plus v. Then. And now, remember, one of the rule, if we have the same base, then what happened? It is equal to u plus v. And then what is u plus v? U is log basis of a, and v is log basis of v. Right? So again, we will see that. We prove that. Okay, so now the next one that I would like to show is actually I would like to show that log base of a to the power of c. Okay, this one. Okay, then now same thing. We would like to do is we replace a with a to the u, and then to this one. Remember, we are going to raise to the power of c, right? Then of course we know that basically this we could have c times u. Okay. And now, same thing, I have these two base, they are the same, meaning I have c times u then. Then remember u is log basis of a, right? So then again, okay. Okay, now the last one, what I would like to show is, I would like to show you log basis of A over B, okay? Now, of course, I could use the technique, right? The first technique to show you, but I would like to show you another way to do this. If you remember that, we could actually write A over B as A times B to the -1 power, right? We could do that because again, B to the -1 equal to 1 over B then, right? Okay. Then now, we could actually use the first rule, okay, the first law, because this is multiplication, so we could rewrite this into log basis of A plus log basis of B to the -1, right? Okay. And then now, to this one, how about if I bring the power -1 down, then I will have log basis of A, positive negative is negative, log basis of B. Okay. Then you will see that I have log basis of A over B is equal to log basis of A minus log basis of B. Then this is actually is the second law. Yeah. Then I show you the three laws now, right? Okay. So then now, okay. Then now remember this is really important, okay? Learn how to use it. Later on, we will do some example related to this too, especially when we get to the section 4.4. Okay, we will do this more. Okay, so now on your calculator, you will see that we have what we call the common log. What is a common log? It means that the base is 10, okay, and then we didn't write down the base 10. Another one is a lot of students confused about the natural log. Now to the natural log, is actually is log base e of x, okay? And then in this case, because we use this log a lot, so we have a new notation to represent it, log basis of x, we call it ln of x, okay, or natural log x. Okay, so then let us look at the common log here, okay? So if I have log base x equal to, okay, I'm sorry, log of x equal to y, for y that, because the base is 10, right? 10 to the power of y equal to x. Then. And now, if you use your calculator, then you could actually, let me open my calculator first. Okay, so then to this one, what I'm going to do is, okay. Now here, if, do you see that where you could find the log? Here is the log, okay? And then in the back panel of log is 10 to the power of x. Do you see that? Okay. And then now, the next button is ln, and then in the back panel of ln is e to the x. So this is actually tell you that the relationship, how log, common log and 10 to the x related, how the natural log and e to the x related. So now, if I have log of 81, then you know that this is the answer right here. And if I using 10 to the power of, again, maybe let me round it to 4 decimal places, 9085, then you will see that we get 81 back. Okay. And then how about ln? Same thing. Now on your note, you have ln of x equal to y, or y that e to the y equal to x, right? So again, now ln of 4, okay, is equal to 1.3863. And then you will see that if I use second and e to the x, right? Again, bring out the e to the x, second and ln, then if I input 1.3863, then you will see that you get back 4, okay? Okay. So then here, now again, I have log of 81, common log, right, is 1.9085. then 10 to the 1.9085 is equal to 81. And then ln of 4 is equal to 1.3863. And then e to the 1.3863 is equal to 4. Okay, so then now, let's see how do we actually write back and forth between the common log and the natural log. Okay, so to this one right here, if I have log of r equal to s, then remember the base is 10, right? 10 to the s must be equal to r then. Okay. And how about this one? I have natural log of x equal to 3y. Then remember natural log, the base is e, so I have e to the 3y equal to x. Right? Okay. And now, how about if we have 10 to the p equal to v, then I know that here I will have log, okay, base 10 of v equal to p, right? But again, the base 10, we don't need to write it out. And e to the a equal to 3t. Then of course, in this case right here, I will have natural log of 3t is equal to a. Is okay? Okay, so then again, to this table, I just rewrite the 3 laws and the 4 properties, okay, using the common log and the natural log. Now, one thing that I would like you to notice is natural log of 1 is 0, natural log of e is 1, okay, and natural log, common log of 10 is 1, because again, the base is 10. And then natural log of e to the x is x, e to the natural log of x is x, okay. Okay, just then. Now, let's try this. So to this one right here, I know that to this, I could have log of 10 squared, right? 100. So then my answer would be 2. And to this one right here, I will have 10 to the power of, again, look at this, how many decimal moving to the right? 1, 2, 3, 4, 5. So I have -5. So my answer is -5. Oh. And 17, natural log e to the 3. Oh, it must be 3 then, right? Yeah. Okay, now the last thing that I would like to talk in this video is I would like to talk about the change of base formulas, okay? So to this one, if I have log base b of x, I could rewrite this into log base a of x over log base a of b. I could change the base, okay, to any base we want. As long as these two bases, they are the same. Then I could rewrite like this. So if I change the base to e, then it will be log base b of x equal to natural log x over natural log b. If I change it to a common log, okay, the base 10, then I will have log of x over log of b. So what does this mean? It means that if I have log base 2 of 3, then I could actually input that log of 3 over log of 2, okay, to your calculator, and then we will find it. Or we could write it into natural log of 3 over natural log of 2, okay? So we will get the same answer as well. Okay, so then let's us look at back to the calculator, okay, to see if this is the case. Okay, so I have log of 3 cosine over log of 2, and then natural log of 3 divided by natural log of 2. Let's see if we get the same result. Oh, we get the same result. Okay. Okay. So therefore, the answer to this one is 1.5850. Okay, running to 4 decimal places. Okay, so then, of course, to this one, it will be log of 11 over log of 5, or natural log, right? Natural log of 11 over natural log 5. And then your answer would be 1.489. Okay. Okay. So I think that I will make this video, that's been this lecture, into two videos. One is actually introduce the properties and stuff. And then the next video, I will talk about how do we actually work out the application or the equation, how do we solve the equations of log. Okay. Okay. So again, to this video, basically I talk about the kind of like the properties and the three laws. Okay. And of course, I also talk about how do we write back and forth between the two forms. Okay. Okay. So let's see you next time. Thank you.